Alright, this is our review sheet for the test. Letter 1, number 1 says X plus energy yields a cation, an energy that would be going to be ionization energy. This is the amount of energy it takes to remove an electron. There it is as it lost one. There's electron. This model here is representing any element in the oxygen family, whether it be oxygen, sulfur, selenium, tellurium. It's showing 6 valence electrons. 2 of them are S's and the rest are P's. And therefore you'd show that we have some empty p orbitals. This is an s orbital. So 16 group element is the oxygen family. That's true. Has 2 half-filled p orbitals. That is true. If you did the orbital diagram, all of them look the same. Can accept 2 electrons to become an ion of -2. That's true for that family. Has at least 4 electrons within the p orbital. That's these 4 here. And this is the one that is incorrect. Has 4 internal electrons. Number 3, the answer is going to be letter C. Gallium would be 4p1, 4th energy level. 1 stands for a p orbital. 1 suborbital. A p has a +1, 0, -1. There's the names of the suborbitals, and the half could be either spin up or spin down, plus or minus, does not matter. So C, all the rest of them would not be included. All have 4th energy level. These are S's, so it would not be for gallium. This is a D, not for gallium. So these 2 are the only ones that have P's. In this case, which element has the smallest radius? They're all ions or ionic radiuses. This would be O-2. The answer is magnesium. And the reason why is oxygen and magnesium and nitrogen all have the same ions they would form. The ions they would form would be in this case it would be oxygen -2. We would have nitrogen, which would be -3, and then we would have magnesium, which is going to be 2+. All of these guys have the 10 electrons that we're looking at here. So they all are in the same energy orbital. Only difference is now the number of protons. And magnesium has the most protons at 12, which pulls the outer electrons in the farthest, making it the smallest radius of the ions listed. Which one's impossible? This 2D is impossible. Some kids are getting some things of this 2p5. This is possible. It's just pushed up into a higher energy level. The 2D is not possible. This would be in more of an excited state. The ground state configuration for atoms in the transition elements, electrician metals, are the middle ones. They should end in D's, and therefore D is the correct answer, ending in 3D5. That would be for a transition element. This one here, for a negative ion of a halogen, halogens all have 7 valence electrons. They all form -1 anions. So normally we would see the electron configuration ending in a P5, whether it be 2p5 or 3p5 or 4p5. But in this case, because it has gained electron, it's going to be ending in P6. And that means the only one we have here is this one right here, 3p6, which actually would be of argon. It is a now, well, it'd be chlorine, gained electron. Now it's like argon, so it would be chlorine, chloride. Same thing here, except for a cation. Again, they're all flipping to a noble gas configuration. The only one that's noble is going to be B. This would be calcium 2+ ion. Next, these are pretty well. I'd actually remove these, I believe, from the quiz. I guess I didn't look close enough. I added this later. This is not on yours, but I added it for next year. It's just a standard matching of some different terms. Electron configuration for arsenic, and longhand, short configurations. There they are. And I listed the up-down arrows. Okay, you can pause the video if you want. And getting lower here, I have the answers right here for these guys. I'm thinking you could do okay with this. This is the mass, 254 is the mass number. There's the proton and the neutrons. The atomic number is 99, and this is the charge listed right here. So the answers are located right there. In lab, we were burned several types of metals. As a result, the different colors and produced, explained in great detail how these colors were produced, indicate a few areas in your life where they affected. Okay, so electrons being excited to a greater energy level. When the electrons return to the original level, it releases energy to form a photon. So there's a picture associated with that. Electron drops down. That's your basic idea of your lab. Now this guy right here is talking about all these different isotopes found, and we can build water molecules with these things. The heaviest would be 21. That means we have, the formula is H2O. So if you were building this thing, you'd have 2 hydrogens, and if the lightest version, and I have the lightest version right here, the hydrogens would each be 1, and then the lightest oxygen would be 16, as listed by the options here. So when you add all those up, you get a grand total of 18. And the heaviest version is going to be with the 2 and the 17. So we have 2 plus 2 plus the heavy version of oxygen is 17. So 17 plus 4 is 21. And this is the heaviest version, and I'll put this up here. And away we go. 4 total options, easily could fill the middle ones.